mix Philbro language with my everyday vernacular. I don't attach endless qualifiers to everything. Nobody does that. So I just say it's true. And what that means is the evidence overwhelmingly supports it.
Right. And if there is conflicting evidence, you would modify the theory, the model, and you would adjust it as so, correct?
Sure. Although I would actually say that evolution is basically an observed fact. It's basically like a scientific law. Now, the implications for it, what does that mean? Therefore, in the past, millions of years ago, all the species were different. That's like a kind of a difference. But anyways, go on.
Okay. Yeah. So the contention I have with evolution is that we don't have any observable evidence of the actual transitioning of for example, like any two organisms. So we have the fossil records. We make these predictions that yes, this is probably let's say evolved from so and so, or these are common ancestors of this and this, but we haven't actually observed this with any instrument, for example. Correct?
First of all, not really. Second of all, I'm going to give two answers that sound kind of contradictory. First of all, no. Second of all, we wouldn't expect to see it. So this is going to sound like a topic change, but it's not. Do you think that plate tectonics forms mountains?
Yes.
But we've never seen that happen.
Sure. Okay, but we can talk about that theory like afterwards, right? We're like,
well, we're not, the point is not to have an actual conversation about orogeny. The point is, why have we never seen it happen? Because you wouldn't expect to see it happen. And that's how it goes for evolution. So it's completely, the fact that we don't see it just happen in front of our eyes is what we would expect. If an animal gave birth to a different species, evolution would just be completely fucked at that point. Pretty near in a way. But then I would also say through like some examples of like plant hybridization and bacterial transformations, I would say we basically have seen like a, what do you want to say, like a speciation change or whatever, kind of right in front of our eyes. But with bacteria, it's kind of impossible to define what a species of bacteria is. They're extremely problematic.
Right, but wouldn't you say this is a limitation or rather a hole? Like, I understand the underground London experiment where we see mosquitoes speciate, but then at the end of the day, they're still mosquitoes, right? So although they change their species, we've observed that, but we haven't observed anything above species. For example, what is it, like class? Genus?
Genus, yeah.
Yeah, we haven't seen that.
No, because you wouldn't expect to see that.
Exactly, because it's a larger time scale. So, but for any... So then we're inducing this. It's a principle of induction that because we see speciation, we're now assuming that it's likely that these are also a change in class and change in genus.
Yeah, I mean, do you not believe in evolution because of this reason?
No, I do believe in evolution. I'm just saying there's a hole in the theory, as in until we can observe.
But that's a feature of evolution. To call it a hole is kind of weird.
It's a hole because for the scientific method to work on this, you would need observable evidence with any instrument. Obviously, we can't see with our eyes.
There are thousands of transitional fossils that we know of.
Yeah, that's point B. We have point A, point B, but we haven't actually measured or observed the actual transition, right? It's a limitation to us because of time. So then we're applying the induction theory, principle of induction, because we see speciation, because we see bacteria evolve, gain proteins, for example. Mm-hmm. We're just assuming if we extrapolate over millions of years or whatever, we can see these two connect.
Same for plate tectonics, same for erosion, same for stellar evolution, same for your mom. Not really. I just couldn't think of another thing to say.
But just because it's same for all these theories doesn't make it okay. Like, doesn't make it like unfailable, right? These are all extrapolations.
Yeah, I don't see the problem.
The problem is it's probably true in this case.
It's almost certainly true. I don't know what you mean by probably, but
I mean, because we're at this point, we're just denying the the whole aspect of the scientific method. It needs to be observable. It needs to be repeatable. And observable doesn't mean by your eyes, right?
I don't know. I don't know why people do this. Like we pretend that, or some people pretend that if you can't run it through an experiment or run it through the scientific, like fucking Jim Bob makes this argument and it drives me crazy. If you can't run it through a scientific experiment, then it's not even science. Well, that's completely false. We don't do experiments on general relativity. We set up observational apparatus that look into the universe and see things like gravitational lensing to confirm it. There is no qualitative difference between that and looking at the fossil record. And there's no qualitative difference between looking at the fossil record and doing forensics or archaeology. Now, you can complain about the resolution, and that's fine. There will always be things that are unknown, but evolution has made the funny thing I like to say about this, and it's funny because of how well it mirrors what you were saying, that we're limited in time, right? Well, yeah. If humans could live for 200 years, that would mean that you and I were 200 years ago, blah, blah, blah. So you and I would have been in our 20s, I think, when the theory of evolution was first published. And we would have sat there and watched this funny idea first pop up and be like, I don't know about that. Or maybe we would have been receptive to it. But then we would have seen the just countless thousands, maybe millions of individual things that confirm it or are consistent with it, like evidence is proof or whatever, that are consistent with it. And I don't think anybody could have lived through that process and then sat there and be like, yeah, it's kind of, it hasn't really done all that great of a job. No, historically, it's done an incredibly unprecedented amount of, it's like, I don't know, it's like people that are New England Patriots fans today, and they're like, man, this team sucks. It's like, you won 6 Super Bowls in like 15 years. Right? Yeah. Well, I wasn't around for that. I was like, well, I mean, okay, but to say the franchise sucks.
No, brother, I'm saying if they've won 6 Super Bowls doesn't mean that they're going to win the 7th. That's what I'm implying here, right? We don't know for sure. Yeah, it's very likely that they will because they're a good team, but we can't make the interpolation that they're going to win the 7th.
To make that, to extend what you just said to what we're talking about now would mean you accept evolution in the past, but we can't prove evolution will happen in the future or is presently happening.
No, I'm accepting speciation currently. We do see speciation. We do see like the acquisition of new proteins in bacteria. But I'm saying we can't make this interpolation that because this is true, that it must follow to the previous, like the transition state. You dancing, bro?
Yeah. In addition to autographed copies of both my books and, of course, Spanky, I'm excited to announce that I now have stickers, tumblers, apparel, and more on my store. Take Spanky, the God-defeating penguin, and can you put that into a logical syllogism with you wherever you go now. Yeah, I don't like science is abductive. It's inductive. That's how all of science is done. I could take literally any scientific experiment ever done, and I could say to you, yeah, but maybe the universe is blanketed in unicorn queef dust, and it changes the photons as they enter our observational equipment and our eyes, and changes what the actual nature of the observation is. So it's not what it appears to be. The unicorn queef dust made the starlight go around the edge of the sun when Arthur Eddington looked at it. Not the mass warping space-time. That's not a thing.
Brother, what you did was you induced something randomly. You just injected the unicorn. I'm not
unicorn queef dust. Get it right.
I'm not injecting anything. I'm just showing a hole that there could be an alternative, and that we haven't actually observed the actual transitioning. Because we can, we're limited by time. Perhaps in the future,
but if it happened, there would be evidence, and we have thousands and thousands and thousands of pieces of that evidence.
I agree that the evidence is overwhelming, but I'm just saying that it's not complete, right? Until we actually
no scientific theory is complete.
I agree. So then you see what I'm saying here, right? There is a hole. That's why I open with probably true.
Almost certainly true is what I would say.
Okay, so again, that's all I wanted to say. That like that until we develop an instrument that can perhaps a hyperbolic time chamber where we can see bacteria evolve very quickly. Then until then, I don't think it's there
Oh,
still is room
you can
for an
do a
alternative.
bacterial transformation like in no time at all. You just swap like this is one of the first things you learn about in cell biology in high school is the bacterial transformation. For the life of me, I cannot remember whose experiment that was. It wasn't Avery. I don't think it was Avery. Maybe it was. But you can mix two different strains of bacteria together, even if one of them is dead and the other is living, and the living one will absorb characteristics of the other, which really is, in a way, like a chicken fucking a dog, and then out pops or maybe a chicken fucking a lion, and then out pops a griffin. It really is about on that level. There's so much simpler organisms that they don't actually have dramatic phenotypic changes like that. But
Have, have we seen a simpler organism evolve into a more complex organism? No, right?
multicellularity has been observed in the lab. Yeah.
We've seen a single-celled organism turn into a multicellular organism.
Yep. An obligate multicelled organism, nonetheless, meaning it literally cannot. Like if you take the multicellular organism, it's not just a colony. If you break it apart, it will die.
Interesting. I didn't know about this experiment, but again,
Yeah,
it still
it
doesn't.
was done with yeast.
Okay, but do they still remain yeast? Different species of
Well, we
yeast.
don't really. This is kind of the weird thing. If we created a new species right in front of our eyes, we wouldn't know that when it's done in the lab. It's not exactly the same sort of thing like with evolution, because evolution occurs in nature, right? But we don't really know what to do with that. And we don't have, as far as I know, there aren't really scientific guidelines toward, okay, like when you discover a species in nature, you get to name it. What happens when we create something for the first time? You know, like a liger. A liger's not a lion or a tiger. And you could say, well, yeah, but it's still a feline. Well, that's family. That's in the taxonomic level of family. But you did through that hybridization, you absolutely did change the species. And then as far as genus goes, I don't
Yeah,
know
but
this
brother,
for cats
ligers
very
can't
well.
reproduce, right? You know that, right? Ligers can't reproduce, so can't
They the
they can't.
majority of the time they can't, but they have produced viable liger tigon hybrids.
No, I mean when you have the liger, that liger cannot no longer reproduce, even with other ligers.
They have successfully created some uh, viable hybrids.
This is going against what I've learned, to be honest. But okay, I'll look into this
It's
further.
super rare. Let me look this up real quick for you.
Okay, sure.
Um,
But okay, while you do that, but I still want to emphasize the fact that we are applying the induction principle, right? And if you look at the definition of the induction principle, it says it's probably true. It's not without guarantee, like 100% true, right? Because
yeah,
we
I know
obviously
it's
cannot
not
do.
deductive. It's not a syllogism. Science is not. No science is like that. Like literally all.
I understand. Yeah, I'm a scientist
That's
myself.
kind of the philosophical nature or whatever of science is that it is falsifiable, and if it is falsifiable, then no idea. I mean, I don't know. Well, okay, I should take that back because that's not. I was going to say if something is falsifiable, then you could never. Well, so I don't know if this is strictly true. Technically, something that is true, absolutely, could be
Yep.
falsifiable, which just means it could be shown not to be true, but it just never will be because it is true. But that's not the same thing as it. That's not the same thing as it is subject to a test of falsifiability. So that would kind of be an equivocation.
Sure. I
My
also want to
bad.
say that I'm not even injecting God here or anything like that. God did evolution or whatever. I'm just saying that there are holes in the evolution theory, the model, specifically right now because of lack of instrumentation to actually measure the transition, lack of time and instrumentation. So I just wanted to put that out there. But that's all I have to say. Um, no, I have an analogy if you want to partake in this. It's a quick little analogy.
Go
You
ahead.
interested or? Okay. So let's say you see a woman and a kid together. They look very similar. You map their like the gene sequence, whatever, and you see that they have the exact same matching sequence, about 50%. So you can assume that 50% is from a father or whatever. Everything else looks similar. They look like similar people. Can you make the assumption here that that is the mother of the child?
That was really confusing. Uh, say that. Say that. I'm sorry. Say that again.
You see a woman and a child together. They're like walking around together. You also map their genome sequence, and you can all the DNA from the mother is found within the child.
Right. Yeah.
The other half probably from a father. Can you assume here that that is the mother of the child?
Yeah.
Wrong. You would be wrong. What if that is the aunt, a twin mother of the child, right? They would have the exact
Okay.
same genome. So my
Yeah,
point
that's
here is that
interesting. But all you asked was, can you infer that? And yes, you can infer that.
you can, but you would be wrong. That's my exact point here with the theory here. So we need an
But you
inference
said
here.
you can't even infer it. But okay.
Sure, my wording was perhaps incorrect, but my point is we all would make that assumption that it's the daughter or the son, the child of that mother. But I'm saying here, if it is a twin, right, they have the exact same sequence, so you would assume that they do have the exact same sequence. My only point here is that the induction principle does, it's fallible, right? And then similarly, evolution has the same ideology here. Because unless we actually use some instrumentation to measure it, only then we can say evolution is true. Right now, it is probably true. It is the leading model. Anyways, that's all I have to say.
Wait, do you think that there are some scientific theories that are absolutely proven?
I'm not sure about like absolutely proven, but I know that there are certain computer scientist theories that are actually proven. So, but that's where my background is.
Isn't that
That's why I make this
isn't that like
comparison.
just some math stuff?
Usually, yeah, but you can prove it without
Well,
a doubt, right?
I mean,
You
of
have to
course,
prove it.
mathematically you can prove it. Yeah,
But that's just why I have this grief with evolution, right? Being completely true, being like, presented in such a way,
but
right?
yeah, I know, but it's just that's how all science is.
I understand, but so we are admitting that there is a limitation, brother.
It yes, as there are for all the others. It's just I don't know. It's
Okay,
weird to
so
place all of your energy in evolution, but we're just
I
going in a
only
circle now. I think.
okay, but okay, sure, we are. But then I'm glad we came to the agreement that there is limitations here and that there are holes and alternative models could be presented. That's all I wanted to say.
Hmm. Okay.
Cool, cool. Thanks for your time, brother.